Alright, after going all over the rules of the derivative, namely the constant rule, addition, subtraction, product rule, quotient rule, and so on, and we're gonna get more sophisticated. We're gonna talk about next the chain rule. And chain rule of derivatives, it deals with the derivative of composite functions. It deals with the derivative of composite functions. So for example, y being the function, y prime being the derivative. So if y is x squared, then its derivative is 2x using the power rule. Now if we have 2x plus 1 squared, is it 2 times 2x plus 1? That's what we're going to find out. So we have a composite function. We have a function 2x plus 1 and then a square function. So if y equals 2x plus 1 squared, luckily we can FOIL this and get the answer. You get 4x squared plus 4x plus 1. To find its derivative, it's going to be 8x plus 4. If you compare to this, it's 2 times 2x plus 1. That will give you 4x plus 2, so you need another 2. So we're missing a 2, and that 2, it's not an accident, it's actually true. That 2 is the derivative of 2x plus 1. So 2 times 2x plus 1 times 2x plus 1 prime, which is 2 times 2x plus 1 times 2, which will give me the derivative of 2x plus 1 squared. And that's where chain rule comes in the picture. The chain rule. So if g is a differentiable function of x and f is differentiable function at g of x. So f differentiable function of g of x and g is differentiable function of g of x, then the composite function f composite g defined by big F of x equals f composite g of x, which equals f of g of x, is differentiable at x, and its derivative f prime of x is, you take the derivative of the outer function at the inner function times the derivative of the inner function. Okay, one more time. You take the derivative of the outer function at the inner function at g of x, and then times the derivative of the inner function. And there's different notations for this. This is what Leibniz, a great mathematician, wrote. In Leibniz notation, if y equals f of u and u is g of x, then you can see basically that y is f of g of x. Just another way of writing it. And both functions are differentiable. Both functions are differentiable. Then we say dy by dx equals dy by du. So you find the derivative of y with respect to u times du by dx, derivative of u with respect to x. And you can see that's dy by dx because you can cancel these out. Alright, so let's see examples about chain rule. So basically, before we see, again, if y is f of g of x, y prime, you do the outer at the inner times the derivative of the inner. Okay, you do the derivative of the outer at the inner function times the derivative of the inner function. So if y equals sine of cotangent x, outer is sine, inner is cotangent, so you do the derivative of sine, which is cosine, at cotangent, you don't change that, then you times by the derivative of cotangent. So it'd be cosine of cotangent x times negative cosecant square x, which is negative, you pull the negative all the way out there, cosine of cotangent x times cosecant square x. Alright, this is the easier way that I know of doing the chain rule. Okay, you do the derivative of the outer and the inner times the derivative. Or you could do Leibniz by letting u equals cotangent x. So you could do it this way too if you want. Say y equals sine of u, where u is cotangent x. So dy by dx is dy by du, du by dx. Derivative of y with respect to u is sine u. Derivative of u with respect to x is negative cosecant square x, which is cosine u, but u is cotangent x times cosecant square x, and the negative goes up front. So it's your call. Whichever way you want to do it is fine with me. So now the general power rule. The general power rule. So the original power rule, if y equals x to the n, then y prime is nx to the n minus 1. So your base is x, but the general one, the base could be any function of x, u, then where u is a function of x, then you gotta do n, un minus 1, same thing, but then you, according to chain's rule, then you do du by dx, or u prime. Okay. So if y equals 1 over square root of x squared minus 3, to use the general power rule, we gotta write this as x squared minus 3 to the negative 1/2. So this is u right there, so the derivative would be negative 1/2. You don't do the derivative of the inside yet. Negative 1/2 minus 1, then times the derivative of x squared minus 3. So n, u, n minus 1, u prime. So that's negative 1 over 2, that's negative 3/2 at the bottom, it's positive 3/2, and derivative of this is 2x. And the 2's cancel out, so you get negative x over x squared minus 3 to the 3/2. Okay, so now the derivative of the transcendental functions, general transcendental functions. We know that the derivative of sine x is cosine x, but what if it was sine u? So if u is g of x, then the derivative of sine u, again it's still cosine, but then you're gonna times it thanks to chain rule by u prime or du by dx. Derivative of cosine u is negative sine u times du by dx. Derivative of tangent u is negative secant square u prime. Derivative of cotangent u is negative cosecant square u prime. Derivative of secant u tangent u times u prime. Derivative of cosecant is negative cosecant u cotangent u times u prime, and derivative of e to the u is e to the u, like e to the x times u prime. So let's look at some examples. Page 206, number 18. F of t equals t sine pi t. Product rule, t is a function of t and sine pi t is a function of t. So we're going to do the product rule. We fix t times derivative of sine pi t, fix sine pi t times derivative of t. So sine u, it's going to be cosine u times u prime. Derivative of pi t is pi, so we put that up front. plus sine pi t is sine pi t, derivative of t is 1 because t is dt by dt is 1. So it's t pi cosine pi t plus sine pi t. All right, number 30, page 206, f of z equals e to the z over z minus 1. E to the u is e to the u times u prime, so e to the u times u prime, z over z minus 1 prime, quotient rule. So e to the z over z minus 1 times quotient rule, we fix the term, times derivative of z minus fixed z times derivative of z minus 1 over z minus 1 square. You have z minus 1 minus z, that cancels the z's out, so you get negative 1 over z minus 1 square. 36, page 206, u of y, so y is the independent variable now, it's just like an x, y to the 4 plus 1 over y squared plus 1 to the 5th power. Now you could do the quotient rule for this, or it might be easier to do product rule, to write it as y to the 4 plus 1 to the 5th times y squared plus 1 to the negative 5. It might be a bit easier if we do it this way. So du by dy, remember there's no x here. That's u prime of y, okay? You gotta understand the notation. So you fix u to the 4 plus 1, y to the 4 plus 1 to the 5th, and then you times it by the derivative of this. This is u to the n, so negative 5 y squared plus 1. Negative 5 minus 1 is negative 6, and then times it by the derivative of y squared plus 1, which is 2y. So we did f g prime plus, let's do the math over here, g. So you fix y squared plus 1 to the negative 5th, and then derivative of that, again, general power rule, so it's 5 y to the 4 plus 1 to the 4th power, times derivative of y to the 4 plus 1 is 4y cubed. Now we gotta clean this up. So u prime of y equals, you have negative 5 times 2y, that's negative 10y, y4 plus 1 to the 5th, and that negative exponent goes on the bottom, y squared plus 1 to the 6th. Over this guy, we have 5 times 4y cubed is 20y cubed, y4 plus 1 to the 4, over y squared plus 1, this guy goes to the bottom, to the 5th power. Alright, so derivative of, we know that derivative of e to the x is e to the x to the u. We just did that, e to the u times u prime, where u is a function of x. What about derivative of b to the x? F of x equals b to the x and then b to the u. And g of x equals b to the u, where u is a function of x. Okay, so let's see, if f of x equals b to the x, then its derivative is b to the x times negative log of the base. And if f of x equals b to the u, f prime of x is b to the u times ln of the base times u prime, thanks to chain rule. Of course, we can easily prove these. Let's look at some examples. 26, page 206. So keep those rules handy while we're going over the examples. 2 to the t cubed. So that's b to the u. So f prime of t is b to the u itself times ln of the base times u prime. Derivative of t cubed is 3t squared. Okay, so 2 to the t cubed times ln of 2 times 3t squared. 42. Y equals e to the sine 2x plus sine of e to the 2x. So e to the u plus sine of u, okay? So e to the u is going to be e to the u times u prime. Derivative of sine 2x is cosine 2x times derivative of 2x, which is 2. Sine of u is cosine of u times u prime times derivative of e to the 2x is e to the 2x times derivative of 2x, which is 2. E to the u prime. So let's clean it up a little bit. So it's 2 cosine 2x e sine 2x plus 2e to the 2x cosine e to the 2x. Please look at this carefully. It's kind of confusing. 48 page 206. Y equals 2 to the power 3 to the power 4 to the power x. That's interesting. Okay, so 2 to the u. So y prime is 2 to the u times u prime. Okay, times u prime. And then you gotta times by ln of the base, right? b to the u prime ln of the base. So now we gotta find the derivative of that, which would be, again, you're finding b to the u, same thing. It's gonna be b to the u times ln of 3 times derivative of 4 to the x, and that comes down. So 2 to the 3 to the 4x times 3 to the 4 to the x times ln of 3 times ln of 2 times derivative of 4x is x times ln of 4. So you have ln of 2 times ln of 3 times ln of 4 times 2 to that times 3 to that times 4 to the x. All that. Very interesting. Okay. So now I have a question. If I say let y equals 1 over 1 plus tangent x squared, find the first derivative and the second derivative. So let's to find the first derivative, let's write it as a power 1 plus tangent x to the negative 2. I'm trying to avoid using the quotient rule. So y prime, that's u to the n, u to the n. So it's going to be n, u to the n minus 1 times u prime. Derivative of 1 plus tangent is secant square x. So that's the first derivative. The second derivative. Now the second derivative, there's a constant. We're going to leave it alone. Remember, c times f of x would be c times f prime of x. And now we're going to do product rule. F times g. So we fix f times derivative of secant square. Remember, this is secant x square. So we're going to do 2 secant x to the first power times derivative of secant, which is secant tangent. So that takes care of f g prime plus g f prime. Derivative of this guy is going to be negative 3, 1 plus tangent x. Negative 3 minus 1 is negative 4 times derivative of 1 plus tangent secant square x. Okay, so it's gonna come up to be negative 4 secant square x tangent x. We have a negative exponent, we throw it at the bottom. Plus, we got negative 2 times negative 3 is 6. Secant square times secant square is secant 4x, and that guy goes to the bottom. All right, 58. Page 206, number 58. Y equals 1 plus x cubed to the power 1/2 at 2/3. We want the equation of the tangent line. Okay, so y minus 3 equals m x minus 2 to find m and calculate the derivative. So a prime 1/2 1 plus x cubed to the negative 1/2 times the derivative of this guy 3x squared. So it would be 3x squared over 2 square root of 1 plus x cubed. So add 2, 3, m is going to equal 412 over 2 square root of 8 plus 1 is 9. So that's 12 over 6 is 2. M is 2. You put that in there and you get your answer. Number 68, page 206. You have h of x. So we have h of x in terms of f of x. We don't have the equation of either one of them. We're given f of 1 is 7, f prime of 1 is 4. Find h prime of 1. Well, to find h prime in general, we need to rewrite this as a power. So a square root is the power of 1/2. Now u to the 1/2. So we do 1/2 u negative 1/2 times derivative of what's on the inside. That's a 0 plus 3. Derivative of f of x is f prime of x. So if you want h prime of 1, we put the 1 in there for x. 4 plus 3 f of 1. So negative 1/2 times 3 f prime of 1. We have the value of each one of these. 4 plus 3 f of 1 is 7. F prime of 1 is 4. And my answer came out to be 6 over 5. Okay, 86 you can look at. And I'm going to go over that. And I am done with 3.4. Next, see you in 3.5.